Rational functions instructions. When we graph a rational function, the first thing we need to do is factor to find the restrictions. And then you need to identify if the restrictions are either a whole or asymptote. We're going to create a table using the simplified version of the function. I'm going to place the wholes and the asymptote on the graph first, and then you're going to draw in the rest of the graph, making sure that you skip over any discontinuity. The first example we have is y equals 4x minus 12 over x squared plus x minus 12. Factor the first, identify the restrictions, x equals 3 and x equals negative 4. We're going to cancel out the x minus 3's and we're left with the simplified version of 4 over x plus 4. The discontinuities we have horizontal asymptote at y equals 0 because the power in the numerator is less than the power in the denominator, and we have a vertical asymptote at x equals negative 4 because x plus 4 doesn't cancel out. We have a whole at x equals 3, and to find the location of the coordinate point, you plug in x equals 3 into the simplified version of the equation to find the coordinates of your whole. 3, 4 over 7. You're going to make a table from the simplified form of the equation. So we take y equals 4 over x plus 4, make the table just like we did last class. We'll place the discontinuities on the graph first, then draw in the rest of the graph. So the way this one is different is the asymptotes still work the same, and now we have a whole at 3, 4 over 7. And then you plot your points, connect your graph, make sure you skip over the whole 3, 4 over 7. The next example we have is a graph with two vertical asymptotes. So we have x plus 3 over x squared minus 6x plus 5. Factor in order to identify the restrictions at x equals 5 and x equals 1. Nothing cancels out, so that means both of these restrictions are asymptotes. Our discontinuities, we have the horizontal asymptote at y equals 0 because we have an x on the top and an x squared on the bottom. Vertical asymptotes at x equals 5 and x equals 1. We're going to make a table with a few more values than we've been doing because we need to see what the function is doing before the first asymptote, in between the two, and after the last one. So we use the original function, plug in -1 and 0 because those are the 2 points that come before the asymptote. We skip over x equals 1 because that's the restriction. 2, 3, and 4 come next, skip over 5, and then we need a couple after 5, so that's why we did 6 and 7 as well. The first thing that goes on our graph are the asymptotes. And then you plot all of your points and connect them, making sure that you don't cross through any of the asymptotes.